Okay, yes, material balance. This is another major part of the course. That's basically what we're doing, Chabo. Let's just look into it. What exactly is material balance? Material balance is the application of the conversion of law of mass to unit operation. Let me come again. Material balance is the application of the conversion of law of mass to unit operation. Now, what is the conversion of law of mass, or better still, law of matter? The conversion of law of mass states that matter can neither be created nor destroyed, but can be what? Can be converted or can be transferred from one form to another. Is that not it? You cannot create or destroy matter, but you can what? You can transfer it from one form to another. So material balance here is application. It's helping us apply that principle that we cannot actually create or destroy anything. We can only move it from one point to another or from one form to another. So let's look very much into material balance. Now, importance of material balance. One, importance of material balance. Importance of material balance. One, it is used in designing a new process. Two, it is used in the analysis of an existing process. It is used in the analysis of an existing process. Three, it is used in industries to calculate. Take note of this number 3. It is used in industries to do what? To calculate mass flow rate. If you followed us on the previous one, you realize that I spoke about mass flow rate. So it is used in industries to calculate mass flow rate of different streams entering or leaving a chemical or physical process. So let's read number 3. Number 3 is the most important part. It is used in industries to calculate mass flow rate of different stream entering or leaving a chemical or physical process. That's number 3. This number 3, don't joke with it because that's like the major thing we're about to be doing. We're going to be looking at the input and output of a unit process. That's the major part of the course. Just take note of that. That's the major thing. Then number 4, it helps to save costs and reduce wastes. It helps to save costs and reduce waste. And then last but not least, number 5, it is used to design a reactor. It is used to design a reactor. What does that mean? It means like you can bring in, don't worry, we'll get there. Let me not start busting our head. So yes, it is used to design a reactor. Those are the 5 importance of material balances. These are the 5 importance of material balance. Okay, let's look at material balance fundamentals. Material balance fundamentals. Okay, these are the material balance fundamentals. By fundamentals, I believe you guys know what that means, like the major things in the material balance that you need to know. Well, we use to also calculate like I said, the mass flow rate entering or leaving the system. So yes, the first one there is accumulation. Accumulation is change in quantity of material inside the system. I know it doesn't sound like it, but then that's what accumulation is. Accumulation is change in quantity of material inside the system. The next one is input, the one that we all know about. Input is what? Materials that enters the system by crossing the system boundaries. The next is output. Output Outputs are materials that exit the system by crossing the system boundaries. When I mean system boundaries, look at this now. For example, if it crosses here, it has entered, so that's input. It enters and it crosses system boundaries. If it exits from here, it's also crossing system boundaries. So the next one is generation. What is generation? Generation are materials. Generation basically takes place when materials are being produced by a chemical reaction inside the system. And then consumption, when materials are being used up by a chemical reaction inside the system. So these things are basically very, very easy for us to remember. Now let's look at material balance. We have two basic forms of material balance. We have the steady state and the unsteady state. We also have reactive and unreactive systems. So we're going to be looking at all. Okay, yes. Equation of material balance. This is equation of material balance. You know, we said material balance helps us to calculate. So this is the equation that we use to calculate. Now the overall equation of material balance is input plus generation equals output plus consumption plus accumulation. What this means is that what enters and what you form, that is what material that enters the system plus what is formed, should be equal to the output plus what you used up plus the quantity that is changed into. I don't know if you get me. So that's why it's like that. So yes, now we can either have steady state or unsteady state when you are dealing with the calculation for material balance. You either have steady state or unsteady state, and then whether unsteady state or steady state, the system can either be reactive or unreactive. Now for unsteady state, unreactive system, now this is it. We're dealing with unsteady state for now. Now when you have an unreactive system, meaning reactants are not consumed and products are not formed, in that case generation will be what? 0, and consumption will also be 0. When that happens, input will now be equal to output plus accumulation. Why? Because generation is 0, consumption is 0. So for unreactive system, unsteady state, input is always equal to output plus accumulation. That's that. Now the next one is for reactive system. Still dealing with unsteady states, just take note. Unsteady state reactive system. Now for unsteady state reactive system, obviously there will be generation of product and then the consumption of reactants. When that happens, input plus generation will be equals to output plus consumption plus accumulation. So this is what there is for unsteady state. Now I'm just going to do a quick change into steady state. So just flow with me. Steady state, yes, steady state. Steady state. Okay, so yes, this is steady state. This is steady state. For steady state, you basically do not have accumulation when you are dealing with steady state. There's no accumulation because you're taking it one after the other. There's no accumulation. So for steady state, unreactive system, take note, unreactive means reactants are not consumed and products are not formed. Considering that there's no accumulation, your equation for material balance will always be input equals to output. For steady state, unreactive system will be input equals to output. Then for reactive system, it will be input plus generation equals to output plus consumption. And that's all there is to know. So we're going to take one small thing to bring us fully into what we're about to get ourselves into. Run now, because what is coming. Okay, let's take a look at this unit process, for example. Let's assume this to be a unit process, whereby we have reactant A to form B and C, and then reactant C now goes to give us D and E, right? Now you're now told that you should write the overall balance for this particular question here. Now, when you're writing the overall balance for this particular question, eliminate the thought of is it steady state, is it unsteady state, is it reactive or is it non-reactive? Did I make mention of any chemical here? No. Did I make mention of any? So basically this is a steady state. It's a steady state because you don't even know the materials that are entering, you don't know what is going in, you don't know what is going out. So, and also this is unreactive. It's a physical thing. It is not reacting. Nothing is reacting. I'm not telling you that anything is reacting, so it is unreactive. So basically, all you are dealing with here is input equals to what? Output. So you are dealing with input equals output here. So that's that. You are dealing with input equals output. So now, if I look at it very well, I have two basic production here. A entered. Abi? First one, A entered. Let's label that U1. What happened in U1? A entered. A is the feed. And it gave what? It gave B and C. Abi? That's B plus C. A equals to B plus C. The second guy that we have here is U2. This is the second process that is taking place here. U2. And what's U2? C is the feed in U2. C is our feed for U2. And what's coming out? Exit. D plus E. The question now is, what is the overall balance? This is the balance for U1, that's A equals to B plus C. And this is the balance for U2, C equals to D plus E. So the overall balance, what will be the overall balance? Now look at it, it's very, very easy. Subject to formula. You know that A equals to B plus C. And C here is D plus E. So all you do is substitute C into equation 1. Is that not it? So you now have A to be equals to B plus, instead of writing C, D plus E. And that's it. So this now is the overall balance, or you call it overall material balance. Choice is yours. But that's it. So look at it very well. I'm going to draw on that one now. Okay. Let's look at this one. As you can see, the major feed here is A, and the component here is what? Is U1. So let's use that. So component U1 tells us that A is the major feed. And then A gave birth to what? A gave birth to B, A gave birth to C, and A gave birth to D. Now component U2 now tells us that D is the major feed here. D entered and then gave us what? E, which is what is here. Also gave us what? F, and gave us G. Are you seeing that? It doesn't stop there. We still have component U3. This is component U3. F enters, H came out, and then I also came out. Are you seeing that? So this is input equals output. And the last one, U4. U4. G is the input. J and K are the output. Now these are the component balance, each of the component balance. Component U1, component U2, component U3, component U4. These are component balance. But what I need, or what you need to answer, is material balance, or you call it overall component balance. So to do that, what do? Now you start substituting. Let's put this as equation 1. This is 2. Sorry, remind you. This is equation 2. This is 3. This is 4. So if 3 has F as the what's it called? Subject formula, as the major guy here, and then G also is the major guy here, I can substitute the value of F and the value of G inside this place. So with that, I will say substitute equation 3 and 4 into 2. Is that not it? So I will now have D to be equals to E plus, instead of F, I will now write H plus I, plus, instead of G, I will now write J plus K. Are we seeing that? And I write J plus K. Now at the end of it, sorry, I have to clean this. The end of it will now be, since this is now, let's label this equation 5, for example. Equation 5. Now we have D here, but we also have D in component U1. A equals to B plus C plus D. All I have to do is replace this D with this D. So with that, I'll say substitute equation 5 into equation 1. So I will say A is now equals to B plus C plus, instead of writing D now, I'll write E plus H plus I plus J plus K. So now that is the overall component balance. Alright, I'll put some questions for you to try out. Thank you very much.